Welcome to this video where we're going to look at two exam type questions. Both questions concern the preparation of soluble salts from insoluble bases. So hopefully you've seen in the laboratory this method of preparing a salt, and I'm just going to go through two exam type questions just so you can see the kind of things that get asked. Now this video is suitable for use with IGCSE chemistry, but actually the first question is taken from an A-level paper. So there's a little bit of link up there between GCSE and A-level, and you might find the first question a little more difficult. You might not, but it's still relevant for IGCSE. So let's get started. So here we are going to react the insoluble base nickel carbonate, and they've been very helpful here. They've given you the formula of nickel carbonate, and so looking at the formula you can immediately, it confirms that nickel has the charge of 2 because carbonate had a valency of 2, and we're going to combine the nickel carbonate with nitric acid. And as soon as you see a salt preparation where you've got nitric acid, you should be thinking, I'm going to make a nitrate. So it says here we use excess nickel carbonate. And why was excess nickel carbonate used? Well, we add excess nickel carbonate to ensure that all the nitric acid has reacted. So to react all the nitric acid. Now that obviously means our mixture will have leftover nickel carbonate in, and you should be thinking, well, how do I get rid of that excess nickel carbonate? And the answer is that you're going to filter it off. Okay, now that's not been asked here, but you should be thinking about that. Now the next question is, why must the beaker be much larger than the volume of acid used? Difficult question, but you need to think about what will be formed in this reaction. We've got an acid and we've got a carbonate. An acid plus carbonate gives a salt, water and carbon dioxide. The carbonate forms carbon dioxide, and that is going to make your mixture, when you're adding the carbonate, fizz a huge amount. It's going to bubble very, very vigorously, and that will cause frothing, and you don't want anything to escape. You don't want any of the liquid to escape out of the beaker, so you use a much larger beaker so you won't get any spillage. So what would you say for this? Well, a large beaker is needed, so the bubbling does not cause any spillages. And if you check the mark scheme, all they're really looking for is bubbling, but I think it's important, just for completeness, to justify why the bubbling means that you need a larger beaker. And we're going to go on to the second part of this question, and surprise, surprise, they ask for an equation. Now they've already given you the formula of nickel carbonate, and it's a solid, and you should know the formula of nitric acid. It's HNO3, and it's dissolved in water, so it's AQ. And as we've got a carbonate, we're going to form carbon dioxide. We're also, as I said earlier, going to form some water, and water would have the state symbol liquid, not aqueous. Some of my students put water down as aqueous. Water isn't dissolved in water, it's liquid itself. So we give it an L. And the salt. Well, the salt is going to be made of the nickel replacing the hydrogen in the acid. Now, nitrate has a valency of 1, and nickel has a valency, as you can see here, of 2. So we need 2 nitrates for each nickel. So we've got nickel, and then we have to show that we've got 2 of them by putting it in brackets. Okay, and that says aqueous, by the way, at the end there. Please excuse my writing. And you can see now that we need to balance it because we've got 2 hydrogen on the right and 2 nitrate. And so we'll put a big 2 in there. It always surprises me that even at A level, that's worth 2 marks. Now, what the question asks for here is, how do you get a pure sample of dry crystals? It's important you would notice the word dry, from a mixture containing the unreacted solid nickel carbonate. Now, we said earlier, in order to remove the solid, you need to filter it out. And you're therefore left then with a solution of nickel nitrate. So, how do you get the crystals out of that solution? Well, you can heat it gently. And that removes some of the water. So maybe to remove half the water. Now, you don't evaporate to dryness because that might cause some of your crystals to break down, to thermally decompose. And you don't want that. You just want to speed up the crystallization process by removing some of the water. So what you then do is allow to cool and crystallize. And then, in order to ensure your crystals are dry, okay, you can dry the crystals on filter paper. So you can just sort of pat them down with the filter paper, and that removes any moisture. And so those are your 4 points there. It's really important that you appreciate that you don't just evaporate the water by absolutely beasting the reaction mixture with a Bunsen burner, okay, because that would cause the product to thermally decompose. Now this question is taken from an IGCSE paper, I think going back to 2014, but I might be wrong. And I've put the two parts together. This was actually over 2 pages on the actual exam. So helpfully, they've given you the method for preparing the soluble salt. But what they've asked you for are questions about the method. So you need to justify why each step is carried out. Well, not quite each step, but most of the steps. So what we've got here is we're preparing copper sulfate. And you'd expect, if we're making a sulfate, it to be sulfuric acid, and that's right. And we're using copper oxide, which is a black powder. So the copper oxide, the black powder, reacts with the sulfuric acid to produce copper sulfate solution. And the solution is a nice, lovely blue colour. But obviously when you're doing the reaction, it gets covered, or it gets discoloured with the copper oxide until you filter it out in stage 3. Now, why do we heat the sulfuric acid in stage 1? Well, that's to increase the speed of reaction between copper oxide and sulfuric acid. It provides energy for that reaction to occur. Now, you'd know whether it was in excess because when you initially start to add it, the copper oxide starts to disappear. And it starts to disappear because it's forming a soluble product. Copper sulfate is soluble. However, when all the sulfuric acid has reacted, you add your copper oxide and no more reaction can occur. So the copper oxide just sort of sinks to the bottom. So the actual answer is here, how do you know when it's in excess? Because when the CuO stops disappearing. and it's filtered in stage 3 to remove the excess Cu. Oh, I apologise for the quality of the handwriting, it's even worse than usual. Now, when we start heating here, crystals start to form, okay, in this hot saturated solution. And the reason for that is that the actual crystals only start appearing when they start to cool. In actual fact, they usually start appearing around the side of the crucible. But the crystals, according to the question, the real crystals start to form here. And that's because the copper sulfate is less soluble in cold water. So as the solution starts to cool, the crystals appear. And that's because an ionic lattice starts to form. And if you said that second part and you didn't bother with the first, you would still get the mark. So as long as you talked about the ionic lattice forming, you'll be fine. State the colour of the crystals formed in stage 5. Well, I've already mentioned that copper sulfate is blue. Beautiful blue crystals. And finish by stating a suitable method of drying the crystals. You could leave it in a warm place or dry with paper towel. And that concludes this video where we've looked at 2 questions of producing a soluble salt from an insoluble base.